Chapter 1, Section 5, Learning Target 2, is about determining the displacement of an object. You might remember that displacement is any change in position of an object. We label that as delta x, or change in x. Examples of this are, if you have an object that moves from 0 meters to 25 meters, that change in position is the displacement. So the displacement for this object would be 25 meters. But if an object moves from 0 meters to 25 meters and then goes back towards the origin, let's say 10 meters, now what's the displacement? Well, this object moved 25 meters this direction, but then you subtract the 10 meters that they moved back, and you're left with 15 meters. The object ended up 15 meters from where it started. That's the object's change in position, or displacement. And what if an object changed 25 meters of position, but then went all the way back to 0? What's its displacement now? Well, since it went 25 meters away and then 25 meters back, 25 minus 25 is 0 meters of displacement. So an important thing to remember about displacement and distance. Distance is the total amount traveled. So when we talk about distance, it's just the total amount, how far. So in this example, this object would have gone 25 meters away, 25 meters back for a total of 50 meters, if we were simply talking about distance. But since here we're talking about displacement, which is a change in position, which is a vector because we have to think about the direction, the displacement is 0. So distance and displacement are two different things. In the reading, you'll find this information on page 81. This is a summary of braking distance. So when we look at the idea of braking distance, which means how far does the car travel while braking or slowing down while an object is coming to a rest, we can use an equation to calculate that distance. Vf is the final velocity. We've seen that before. Vi is the initial velocity. And in this case, this is a squared measurement. A is the rate of acceleration. And in this case, it is a negative acceleration because the object is coming to a rest or slowing down. And d is the braking distance, which we call the displacement, the change in position. So in this situation, because an object is coming to a stop, we know that the final velocity is going to be 0. So the final velocity is 0. And since 0 times 0 is 0, we put that 0 in for the final velocity. So if we want to solve this, we need to rearrange this equation. So we can now get an equation that looks like this. The initial velocity squared would be equal to negative 2 times the acceleration times the displacement. And again, if it's more helpful for you to use a circle method, that is shown here. This is how you would set up the circle for this equation. There is another way to find displacement, and that is by using a velocity time graph. On a velocity time graph, the area between the data line and the time axis will tell you the displacement. So in this case, if an object is moving with a constant velocity, we would take the information from the graph and we would fill in the shape. In this case, it's a rectangle. And we would find the area of the rectangle. The equation to find area of a rectangle is base times height. So if the height is 10, is 10 meters per second, because that's the velocity, and the base is 5 seconds, when you multiply that, you get 50, and the seconds cancel out, so you're left with meters. Your displacement measurement should have the units of meters. That's how far this object traveled, or the change in position of this object in those 5 seconds. Let's do another example. What if we have an object that is slowing down? And this object starts with a speed of 20 meters per second, and after 10 seconds has come to a stop. Now we would find the area, and in this case, the area of a triangle is 1/2 base times height. In this case, the base is 10 seconds, and the height is 20 meters per second. So we take 1/2 times 10, we get 5. 5 seconds times 20 would equal 100 meters, because again the seconds cancel out. So this object traveled 100 meters during the time that it was stopping. You now have 2 practice problems to complete. In the first one, you're given a situation and you need to figure out the car's displacement. You may want to use that circle method that we talked about to figure out what the displacement d of the car is. Remember, this would be 2a, and this is v squared. Read the information of the problem. Use the equation tool that we've shown before, where we have what we know, what we're given, what we want to find, the formula, etc. And determine the displacement of the car. Hit pause so you can solve this problem before moving on to the next problem. In this practice problem, you're going to use a graph to find the displacement of the object. So use the data that you're given on the graph, and as we mentioned, find the area of the shape. That will tell you the displacement of this object. When you have completed the practice problems, you can show them to me, and I will let you know if you have them correctly done. Thanks!